Okay, your head is probably spinning a little bit. I got to get rid of this old one. All right, here was where we were. Let me go ahead and go to play from current slide here. All right, here we go. So that's what we did, and here's how I figured all that stuff. Broke it down into its vectors. It's a projectile motion thing. The only place where the acceleration happens is in the y direction. They use a different formula than I did. They're using the vy squared. You know, I hardly ever use that formula because I want to start with the time. You can't do a damn thing in physics without the time. Okay, you need time. This formula is for sissies. Let's get the time first. Okay, what is the time of the flight? Well, we know we can. They are. I like what they're doing here because they know that the only place to find the height is in the we got to find the time first. We got to find the time, and then they use the formula that I did. They're finding the total time of the flight. They are finding the total time of the flight, and what are they doing here? Okay, yeah, they're finding the total time. I don't see what they're doing. Oh, I know what I did. I went ahead and they're multiplying 2 through the whole thing. This is confusing because here's really what they're doing. They're saying, okay, to find the total time of the flight then, I'm sorry for the pause there. Another way to find total time, which is what they're doing in that slide, is this. I know that v final y is going to equal negative 14, what did we say? Gosh dang it, 14 point, negative 14.2 meters per second. I know that that's going to be the final. So I can do negative 14 meters per second is equal to 14 meters per second minus 1/2 9.8 times t squared. That doesn't say what they did, but you can do it this way too. You can do it this way too. So I subtract minus 14, I get minus 28 meters per second on both sides equals minus 1/2 9.8 t squared. I take 2 times, the negatives cancel, 2 times 28 divided by 9.8, take square root of it, and I'll get 2.9 seconds. It's flexible, it can go either way, all right? But the key was, I just want to show you, we worked it out correctly. All right, but here's what I wanted to talk to you about. Notice, if I throw from the top of a cliff, a person throws 2 stones. One, and they throw them at the same, one's at this angle going up and one's at this angle going, at the same angle going down. Okay, notice the x component of both of these are going to be the same. So when it reaches over here, the x component of the rock is going to be here. But notice what happens. This v naught y going up here, and then it comes up, and then the y component equals 0 here, then starts gaining, and it comes here. This has the same magnitude and direction as this one that they threw down. Okay? Because it came up, if I throw it straight up in the air, it's easier to think about. If I throw a rock straight up in the air, there's just some little nuances here. If I throw a rock straight up in the air, like this, okay, at say 20 meters per second, during its flight straight up and flight straight down, it's going to be slowing down and slowing down. But that would be the same, it's going to be going the same, the minus 20 meters per second here when it's coming down. That's the same thing as what they were showing you over on that one slide. Okay? We're not going to mess with that. We got bigger fish to fry. I need to get you all to thermodynamics. And because we could spend 2 weeks on projectile motion. So I gave you it's basics. Is it easy? No, but it's the basics. All right. So let's go back to their little slideshow here. And let's talk about relative velocities. Okay. The velocity of the person to the ground observer, that's PG, is equal to the velocity of the person on the train. He's walking at 2 meters per second this way. The velocity of the train to the ground is going 9 meters per second. So the velocity of the person, this person here to the ground observer, is the velocity of PT plus the velocity of TG, train to ground, person to train, train to ground. Notice the T is on the outside here and on the inside here, and so that cancels, and I get PG, and you just add the two, 9 plus 2. And that's all we're going to do. We're not going to do this kind of stuff right now. We're not going to do that. We don't have, I mean, there's only so much we can do in 14 weeks and meeting twice a week. So that came out to be 11 meters per second. So let's take a look. Let me show you how to do these problems. All right, let me show you how to do these. Here's what we do. All right, let's say, and we're going to make this a little easier. Okay, so let's start off this Tina Turner. Let's start off nice and easy, and then we're going to end a little bit rough with this. We're going to talk about relative velocities. All right, so I've got a car. Okay, and it is going 70 miles per hour. We're not going to change. We're not going to mess with changing. We don't need to make it meters per second. We'll just leave it as 70 miles per hour in the positive x direction. Okay. I've got another car approaching. Now they're in different lanes, so they're not going to crash into each other. I've got another car approaching. Okay. It's coming this way at 65 miles per hour in the negative x direction. All right. So I'll make this one the velocity of car A to the ground is equal to positive 70 miles per hour. The velocity of car B, this is A and this is B, the velocity of car B to the ground is equal to the ground is equal to negative 65 miles per hour. Okay, so what is the velocity of car A to car B? What is the velocity of car A according to car B? Well, here's what we do. We go to the velocity of AG plus, now remember, I want to get A and B. So I'm going to keep my two outside subscripts here. So I want B on the outside subscript, so I'm going to put B here and put G here. When I flip-flop these guys, this becomes V of GB is equal to positive 65 miles per hour. That's the way that works. So now my subscripts cancel like that. I've got V of AB is equal to V of AB is positive 70 plus V of GB is positive 65. So that's 135 miles per hour. The velocity of this car, according to this driver, is coming at him at 135 miles an hour. That's why when you're going eastbound on I-70 and somebody's going westbound on I-70 and you're both going 75 miles an hour, that westbound car looks to you like it's going negative 150 miles an hour. Whew. Zooming past. And that's how you do relative speeds. Sometimes you get things that look screwy. Sometimes you get things that look screwy. And now I'm going to pause. I learned how to pause this, but I've forgotten already. I think I hit